Okay, here's your area volume problem. Okay, I'm going to just outline F on the top with just purple, okay, so I can see the difference. It says find the area of the shader region. Okay, I'm going to start by drawing my rectangle. Notice if I draw this rectangle in, notice it's always the purple minus the bottom graph, which is G. So I know that I only need one integral. So the bounds are 0 to 1, which they show you in the graph. The top is the purple, which is F. The bottom is G. That's the height of the rectangle. The width is dx. And you can use these because they have defined it up here. Type it into your calculator. I get 1.133. Part B. Find the volume when we are revolving about line y equals 2. So draw your line y equals 2. It's somewhere up here. Now, I know, so you're going to have to decide whether I should use shells and washers. I look at these equations. It's already set up to do dx. It's going to be very tricky to do it for dy. So I'm going to leave it as dx. So notice I am perpendicular to this line, right, this rectangle. So that means you're going to be washers. And notice there's a big gap here between the axis of revolution and the region. So you should be thinking, oh, I have to do a pi and a big R squared minus the little r squared. Remember, your big R has to cover from the axis of revolution your whole and the entire graph. So this is your big R right here. So notice the big R is 2 top minus the bottom goes all the way to G. So my big R in this problem is going to be 2 minus G. So big R squared. There it is. I'm going to put the pi outside of everything, and I know I will need the integral from 0 to 1. Minus, what's my little r now? The little r is just the whole. This is my little r right there. Notice the top of little r is 2 again, but the bottom is f. So my little r looks like this. It is pi big R squared minus little r squared. And type it in your calculator, and this is the numerical value. Lastly, part C. They say there's another function h, which is defined by this. I don't know what k is, but looking at this factored form, I know that the x-intercepts are 0, it's factored, and 1. And if you plug in any value for x between 0 and 1, the graph will always be above the x-axis. So it's somewhere up here again. I don't know exactly where it is. It really doesn't matter as long as you know that's above the x-axis. So let's draw another, I'm just going to say there's another graph somewhere up here, and let's call that h. So this time I want cross sections perpendicular to the x-axis, so I know I'm going to use dx, and I want the cross sections to be squares. So I'm going to draw in my rectangle. Notice the rectangle is always h minus g. So draw and think about your square. This side is always h minus g. How do I find the area of a square? Side times side. So the area of the square is h minus g squared. That's the area. I want volume, so you'd want to do dx, and the integral goes from 0 to 1. So this is your setup for the volume, and they say write an equation that could be used to find the value of k, and they told you that this volume is 15. So this is what they're looking for.